Knowledge. Liz, whose sister had participated in this program in the past, interested in systems engineering, and I think she ended up with a good project for that. Evan, looking for an opportunity to experience some of the facilities we have here, and Alex wanting to get in a team environment and learn a little bit about working with teams. So. Alex's comment is actually kind of funny because he was in a rhythm or percussion section, and so his little fun about rhythm kind of stood out. Liz is bringing up kind of a good point, right? We really want to encourage women to step forward and participate at a full level at this event and in engineering as a whole. Evan discovered some of the challenges of teamwork sometimes, and then Alex with an interesting thing there. Fully virtual worlds, which probably enjoyed some of the tours that we had this week. So I'd like to invite them up.
We are the networking team. My name is Liz Halter.
I'm Evan Safer.
I'm Alex Jeff. I'm Alex Safer.
So we were focusing this week on a networking project. So we had a few different aspects of our project, and we're going to tell you about what we learned over these past few weeks. So the first phase of our project was networking basics. None of us really had a working knowledge of networking, so we really had to build from the ground up to learn exactly what networking was and what the fundamentals of it were. So what is networking? Networking is just linking machines to operate interactively. So it could be computers, it could be brains, it could be anything. Where they're communicating, they're working together, they're talking via wires, wireless. That is a network. So our goal for these past 2 weeks was twofold. The first aspect of our goal was we wanted to build a working knowledge of what networking was and the basics of networking. And our second goal was to build a functional complex network out of switches, which we'll talk about later in the presentation. So the first thing we had to learn about networking was how computers identify themselves. And computers identify themselves actually in two different ways. The first way is with an IP address, which stands for Internet Protocol. And an IP address is one of the identifiers of a computer that's completely programmable by the person who owns the computer. So the person who owns the computer can set the IP address to anything that they want it to be. The second way computers identify themselves is with a hardware address. And a hardware address is permanent and an integral part of the computer and cannot be changed. So computers use both these, the IP address and the hardware address, to communicate with each other using ARP queries. So ARP queries, which stands for Address Resolution Protocol, is a protocol for mapping where computers are in a network. So you can think of an IP address as being someone's last name. And you can think of the hardware address as being someone's first name. So the way ARP queries work is the first computer calls out, who is Smith? Who is this IP address? To all of the computers on the network. And all the computers on the network look at that IP address, and the one who recognizes that as themselves will respond, I am Larry. They will respond back their hardware address. And that first computer then knows where the other computer that it's looking to communicate with is on the network.
Switches are used in networks to sort messages and send them to the appropriate device. Our group had switches made by Juniper Networks, which have their own syntax and operating system. Each of the switches had Ethernet and fiber optic ports, and they can be configured either with a direct console connection or remotely. When multiple networks need to be connected, a router is used. Routers store IP addresses in routing tables where they know what path is used to get to each IP address. When a router receives a packet, it searches the routing tables to see where the next stop it needs to send it to is. And the best route is determined by the protocol in use, which in our project we use different protocols. So our goal in our project was to use our 8 Juniper switches to create a functioning network with 2 routes to each console in case one route were to fail. And we configured our switches to act as routers
before we actually created our full 8-switch network, we separated it into 4 what we called pods. We each had 2 switches. We called them the northward switch, this one, and the inner switch. And so we all each made our own 2-switch network first. And so we connected the 2 switches using a fiber optic cable, which is shown over there, the orange cable. So inside there is a glass wire, and it uses lasers. It bounces the lasers around inside, so lasers are actually used to transmit information. And what we did on this network was we created groups of ports that we call VLANs. And VLANs stands for Virtual Local Area Network. So the ports that we put into a VLAN can talk to each other as if they were on a physical network together. So as if they were all on the same switch, for example. And so that blue box represents what we call VLAN 29. That was one of the VLANs that we created. And since we did make this VLAN, these 2 ports, shown by the red arrows, could communicate to each other with some messages. And since these 2 were outside of the VLAN, they could not send messages. So then after that, we started to create our 8-switch network. So we had to switch out all of our connections, and we switched to mostly using Ethernet cables to connect switches, which this is over here. And inside there is copper wire, and it uses standard electrical signals to send information. And like Evan was saying, we use routing protocols to send signals between switches. And we use OSPF and RIP. And I'm about to explain this one. So we use OSPF on this main inner network right here, these 4 key switches, the inner switches. And so what we did is we configured OSPF, and that allowed us to see on each switch we could see the entire inner network. And so that's what OSPF does. And also OSPF does what its name suggests. It stands for Open Shortest Path First. And so it will figure out what is the shortest path between the address you're sending a message from and the destination address, and it will send the message down that path. And we used the other protocol, RIP, for the outside top and bottom green open switches. And the difference between OSPF and RIP is that RIP was actually an earlier protocol, and it's less sophisticated. So in OSPF, you can see the entire network, but in RIP, you can only see whichever router is closest to the destination. Also, in OSPF, since it can see the entire network, it can tell when a connection is down, and it can reroute your message through a backup route if you made one. It can do that within a few seconds, but if a failure happens in a RIP connection, then it will take a minute and 30 seconds to reroute, and in a business situation, that is actually very good.
So in order to test our network, we used mainly 2 commands. The first one was the ping command, which showed us the time that it took to go between two switches on a network. And it would send, it acts kind of like a game of Pong, and it will send a ping message, and it will wait for a response called the Pong message. And when it receives that message, then it knows that the connection is working and that you can access that router. The second command, the traceroute command, shows us the connection through each router, and it uses the ping command in the background to go down for each router that it finds, it pings it, tests how long it takes, and make sure that that connection is working, and it keeps going down the line. When we use this command to test primarily because when there is a failure in our network and we're unsure of why we're unable to connect to a certain router, we can use the traceroute command and see exactly what connection is broken. For our final project, project, we created this router configuration that Alex talked about. And in this configuration, all the networks were physically connected to some other router. And they were all able to talk to each other except the fourth Northwood and the green one at the bottom there. It was unable to talk to any of the blue switches there, the pinner switches. And using the traceroute command, we were able to discover that it was the connection between pod 4 and pod 2, the one in purple. And given more time, we would have been able to fix that issue and set up a secondary connection for each of the routers to connect to all the other ones in case there was a failure like this, that we could still talk to all the other routers. But we ran out of time, and the configuration for each of these two protocols is fairly difficult, especially for the Northwood routers.
So we'd like to say a huge, huge thank you, mostly to our mentor, Dr. Ram, or Mr. Ram. And he gave a lot of time to us, and he gave us so much knowledge, and he shared so much with us. And we'd also like to thank all these other wonderful people for being here for us and giving us a sufficient amount of gummy worms throughout the week. So does anyone have any questions? Okay, yes.
Did you do any other network trafficking other than pin commands and trace routes? Try to move any packets or anything?
We didn't get to that point. We didn't have full connectivity to the point where we tried to plug anything into our routers and actually send information on our network.
And I just looked add to that. In our first configuration, when we had the two routers just on our own little station, we did actually connect our computers and make sure that we were able to connect between multiple computers on that network. But the secondary network, we were running.
But what's the hardest hurdle you have to walk through this project?
Personally, for me, the programming, you have to program all these switches by hand. It's all in command line. And the programming is kind of unique on this one, and I didn't have a lot of programming experience, and I know some of us had a lot of programming experience, but for me, that was my personal biggest hurdle, was learning the syntax for everything.
What kind of programming did you use?
Sorry?
What kind of programming language was used?
So, like Evan was saying, Juniper switches do have their own syntax, so they have their own language that they use for it. So it's not like anything else than Java or Python.
Thank you.
Anyone else? So in our presentation, we hid a few Easter eggs, if anyone noticed that. You can see in one of our pictures, we actually have a banana on the telephone that's connected into our network. And then also, this was the hardware address that we mentioned earlier, and hardware addresses are written in hexadecimal, and Q is not a valid hexadecimal number. So that would be an inoperable hardware address. So thank you so much.